For P5-10, the rotator assembly, I'm mixing up the order a bit. I would like you to go through and attempt the parts on your own. We're going to follow the instructions at the beginning of the project. We're going to make an assembly drawing, an exploded isometric view with assembly numbers, parts list as the bill of materials, and they're asking that we remain parallel on the crosslinks. We won't really see why that is until after we've made the assembly. So, and then we'll also put this into an animation, although you won't need to turn in any animated videos as they get quite large. All right, so at this point we're going into the assembly. There is a video for the parts if you get stuck or have trouble with them, but take them as far as you can. This geometry is pretty straightforward, so should not give too many issues. So looking at the rotator assembly, choosing the part, I am going to recommend, and you're going to see this, we've done a few intro videos in the introduction. The recommendation is always that you bring in one part at a time, get it situated, location, orientation, position, all of those fun things, that it is where you want it and doing what you want, and then bring in the next piece, and then bring in the next piece, and then bring in the next piece. And that at that point doesn't really matter the order, it's just one at a time. It'll save you a lot of headache of a lot of different things going on at once. All right, so the assembly, depending on how we set this up, we're going to go into new, pick our assembly, and I am in inch, pounds, and seconds. That doesn't play a part because we're not dimensioning the sketch, but as I'll mention in the parts, if you missed the units and you drew this in inches, your numbers at 15 and 30 are going to make really huge parts. And some of them, if they're in metric, are going to then be really small parts. So you do want to pay attention to units, but we can switch back and forth between inch and metric in the assembly, and it's not going to have any major issues. All right, so for this, we're going to stay with insert components. As we go more into the introductory projects, I've allowed time to review that information so that you have plenty of opportunities to see how these all fit together. So when I insert the components, my three items that I've created are still open, and the plate is going to be my choice. And because it's drawn in the front plane, when I go to the OK, it's just going to position it. If I click anywhere in the work area, it's going to position it, and the origin's going to be a little bit off. Not a big deal. It's just when I look at the origin, I know that I put the origin on the part there, and it aligns origin to origin and applies it as fixed. If it comes in any other way, we'll probably go ahead and build it this time and not worry about it. But if it becomes something that you do want to change, the F is for fixed, and when we float it, that will go away. So we're going to do more of those, but go ahead and click the OK so that it places, and then we're on to inserting our link L's. All right, so insert component, because they are open, they're showing up in the list, and I can drag them into position. Now this one I do not want to be fixed, so lining it up and trying to just visually put it there, that's not the point. We want, besides it's backwards, so since I have the rotate X, Y, I would rotate about Y. On one of my computers that doesn't show up, and I haven't figured out where. I'm pretty sure it's checked over here, the show rotate context, and for some reason I've lost it off the screen somewhere, or managed to to not be able to find it. So we can also right click and do rotate. And same thing is I can get it kind of close, but if I really go to look at this, I'm off and I'm off again. So we don't really want to leave those just anywhere. So we're into our select control select. So the hierarchy is going to be faces and afterwards edges. Right, so a cylindrical face to a cylinder to a bore will be concentric. And then if I want to see where this contacts to the back of the part, or possibly where the end of the shaft contacts or penetrates through the back of the part, I could go that route as well. So we're going to select the face of the plate, control select the link, and make those coincident. Let's see that that kind of flushes out. All right, so this is where we get into degrees of freedom. Right now, this only has 1 degree of freedom rotating about Z. So when we talk about translation around X, Y, and Z being able to move, that is 3 degrees of freedom. Rotation about each of those axes is then our other 3 degrees of freedom. So when I say we have 1 degree of freedom left is because the link is free to rotate. All right, so we did the insert component. If I hold down the control button and I drag from the tree, or I hold down the control button, shift select, or select, I got shift on the brain all of a sudden, control select and drag, that's going to bring in another instance. So these instance counts, 1 and 2, are just increments of value. If I were to delete 2 and bring in a third one, it'd go to 3. We're not going to worry about them being out of order or not having a 2. But since they're in order, we're ready to select the bore and then control select the shaft, and then we can go concentric, select, control select, and we'll talk about what just popped up there pretty quick. So I lost that one. Hold down the control. And you're going to get really good at rotating with the middle mouse button to change the view to make these coincident. And then the little double arrow is for mate alignment. All right, so let's do the last one of these with the mate, and we'll talk more about why that works. So let's insert the component. Since this is a regular piece, comes into the view. So doing the control button is if I'm selecting out of the work area and I'm waiting for the context. That's always going to be fastest, but if it doesn't cooperate, isn't working, we go to the mate paperclip, and now we're just picking. I can select the cylinder to cylinder, and it will give me the same item. And then if we didn't want this to turn, I could lock rotation. In this case, we do want it to rotate. So usually the lock rotation is good for putting in hex bolts or cap screws or panhead screws. And whatever position they are rotationally, it doesn't matter. I'm just looking for the length and that they're seated to whatever surface. So that would be when we want to lock rotation. So I'm able to move, and this is now going to be a select. And again, I'm in the property manager for the mates. So all I have to do is select the faces, and then we're going to go ahead and accept. All right, so this one should line up with this one. All right, this face to this face. So at this point, I'm still in. My fingers are migrating towards that control key, but I don't need it. And then as soon as I place the 2 faces, now they are in line. Okay, so the mention of staying parallel. because if we rotate this enough, there is a spot, there it goes, there is a spot where this will become more of a crank arm than a follower rotator. Now, on the mechanical side, knowing that it does that, we don't have any mechanism in the real world to, in this design yet to keep it from doing that. So we would have to come up with a way or limit to the motion to keep those aligned. But it does tell us that there is a place where it will move and it can get there, so we just have to be aware of it for now. All right, so I'm going to do the select control select and go parallel and see if it pops up. All right, so this one is just the flip mate alignment. And if we flip the mate alignment, that is an alternate solution. All right, so if this, if I'd gone coincident and it put it into the part, I would have flipped the mate alignment. The other concentric is to lock the rotation. Pops up on that little context and keeps it from rotating, which is the same as if we were to go. So if you do accidentally click it, the concentrics are going to have lock rotation and all of the mates are going to have the ability to flip the mate alignment. All right, so now this is able to move, and for the drawing, I would like it to stay in position. And if I move this in the assembly or it does something, I really want this to be static. So these minus signs are telling me that the rotation and the movement is because I have only controlled 5 degrees out of the 6 degrees of freedom. So that face is already selected. I can hold down the control button, select the in face, and I'm just going to set an angle. 30 degrees looks good. And let's see what happens if we do flip the mate alignment. May not like that one. There it goes. Goes to the opposite 30 degrees. All right, so to the, not going to be the adjacent angle. Yeah, I don't remember that one. All right, so then flipping the dimension is another option. Sends it that way. So you have choices to line this up. The main thing is we are going to be able to have as a default our static item. When we go to animate this, we're going to set up a configuration. Configurations are very handy to control the properties and building these parts and watching them move. So let's go ahead and save this as the rotator assembly. And then watch the parts next to see how I did it, and then we'll go into the drawings in the video after that. So let's save, and we'll be good there.